All right. Hello, everybody. This is the week 4 lecture of the Psych 3280 Neural-Based Consciousness. This week is going to be the introduction to the visual systems. Okay, so just let's get started with the recap of the week 3. I first discuss about the role of the brain lesions in consciousness research. And then in particular, I introduced the brain lesion patients' phenomenology and their behaviors. And in terms of the example, I first discussed and also showed the movie example of the locked-in syndrome people who couldn't, who basically can't move anything about their body except for their eye and eye blink and so eye movement sometimes. And we looked at the video of the butterfly and the bell, diving butterfly and the bell. And then we also looked at patients who were discovered to have no cerebellum, but didn't have much impairment throughout her life. And then prefrontal cortex. So we discussed about a guy who got steered their left to right prefrontal cortex bilaterally, and although he had some social interaction problems, but he seems to be intact in terms of sensory experience. And then finally, we discussed about the blind side patient who had a lesion in primary visual cortex mainly, and then demonstrated their various interesting behaviors and also interesting phenomenological reports. And in particular, blind side patients claim that they do not experience anything visual. So that's their phenomenological behavior, reports. However, their behavior, especially the localization behaviors, are quite intact. And that's the dissociation between the phenomenology and the behaviors. And this is a key figure from last week. GY is a patient who is termed as a relative blind side person. Relative because his blind side behavior happens only at a certain range of the stimulus strengths or luminance contrast. And we also talk about absolute blind side this week again, but in his case, it's relative blind side. And then these two sets of the bars here is two different experimental situations when experimenters change the frequency of the stimuli. But even though the stimulus presented in the blind hem field was quite frequent, 20%, the high contrast stimulus, such as 30% or 46% stimulus, was almost always not detected and reported as absent here. That's the correct rejection component here. And notice that in the intact field, he was able to detect 3% stimulus, 100% accuracy. So 30 or 46% is much stronger stimulus, but he still denied seeing. Okay? And then the right side figure shows that the report of seeing something, that is a white square, there's some kind of fluctuation. And the black is the key here. It's the accuracy of the localization judgment. So here, the test was to present two possible location of for the target, and then blind-sided patients were asked to locate which box contained the target. Okay, and then if you just ask them what they see, especially for the stimulus such as 38 or 46, then they just would say that no, I don't see anything. But if you ask them to choose either one of this, then they can say, they can just point it, touch it at an accuracy of 80% or more. Okay? The right side is the accuracy or proportion of the trial where they saw, they reported seeing something. So here, chance performance is 50%, and they were correct at 80%. It's a dissociation. Okay. So in this week, following from this blind side discussion, what we are going to do is to introduce a way to validate phenomenological reports of blind side patients through consideration of metacognitive accuracy. And metacognition is a concept, and you can consider it as a knowledge on one's own consciousness. And then we also introduce a basic architecture of visual system, focusing on the structure and function of the eyes. And then we will follow and also build more knowledge based on the visual system from the next week further. So learning objective-wise, it's going to be the following. First, what are the behavior and the neural signature of non-conscious processing? So blind side behavior is quite surprising on its own, but I haven't actually explained what's actually happening in most of our normal people's unconscious behavior. So once you understand what we can do with the non-conscious processing, it will become even more surprising why blind side behavior can happen. And then to back up whether back up the argument whether blind side behaviors are just a consequence of lies or insensitive kind of methods, we first review further evidence whether blind side behaviors can be induced by monkeys. And there, the experiments are much more carefully controlled, and we can do more interesting experiments, and also to understand better. So then we'll discuss what are the evidence of the blind side behavior in monkeys. And then after establishing the difference between the standard non-conscious behavior and the blind side behavior, and also confirming that the blind side is a reliable, replicable behaviors, we go to this. We are going to discuss how we can discriminate non-conscious from conscious behaviors using the concept of the metacognition. And then towards the end of the lecture today, we are going to discuss how is what is the structure of the eye and how does it shape our conscious vision. And this is a relatively big topic, so it's likely to go span across into the next lecture. So in terms of the reading material, it's especially the last one is going to be covered by chapter 3 of the Quest for Consciousness. And if we can't cover everything this week, then we will not assign any reading material for the next week. Okay, so we'll start in the next video.